this problem, we're solving for a projectile that is launched horizontally. We're going to start off with things being launched horizontally before we get to things launched at an angle. Problem reads that a person standing at the edge of a seaside cliff kicks a stone over the edge with a horizontal velocity of 18 meters per second. The cliff is 52 meters above the water surface. How far from the cliff's base does the stone land? So these problems, we first want to draw a diagram. The diagrams will help us, especially with our directions and positives and negatives. And so the only thing we're going to write in terms of number on the diagram is our distances. And we know that this stone falls 52 meters to the water, but we don't know how far it has gone over. That's what we're looking for our main goal. We had said in the previous tutorial that our x and y directions and motion are separate from one another. They're independent from each other, we say. So we're going to write our givens in terms of the x and y direction. We can see from our equations that in the x direction, we really only have two things, velocity and displacement. Time is, of course, independent of any direction. So if we know them, we'll write them down. But those are things that we are looking for. In the y direction, we can see from our equations that the things we're looking for are the final y velocity, the initial y velocity, the acceleration, and the displacement. Again, time is independent of any direction. Again, there are two velocities in the y direction because it is accelerating in the y, but there's only one velocity in the x direction. Notice we don't have vix and vfx. The reason is because the velocity in the x direction is constant. And so there is only one. It's not changing. So let's write down our values. The first thing we can always write down in projectile motion is the acceleration. And that is only in the y direction. There is no acceleration in the x. So that is negative 9.81 meters per second squared. We also see that it's a horizontal velocity of 18 meters per second. So look for those keywords like horizontal, and that means that the velocity given is the x. Horizontal means in the x direction. But not only that, if we look from the diagram, we see that it is moving only to the right in the beginning. It is not moving up or down in the beginning. So the initial y velocity in this situation is 0. So if it says horizontal, we know the x velocity is the one given, and the initial y is 0. We know that the stone falls 52 meters. So I can see from my diagram that it is 52, but it is negative 52 meters. We want to find how far from the base of the cliff it lands. So we're looking for delta x. Now we don't know vfy, and that is typically the case. Usually we don't know vfy. It's not always the case, but it is often the case. There's also time that we don't know, and that is independent of either direction. I'll kind of write it down to the side because of space. So we want to solve for delta x. If we go to our equations, we notice that we're in luck. There's only one equation with delta x in it. Unfortunately, although we know vx is 18, we don't know delta t, so we can't solve for it right away. My hint to you before was if you can't solve for what you're looking right away, find time first. And we see that that's what we'll need. We'll need time to use that equation. But not only are we going to solve for time, we're actually going to use the other direction when we solve for time. And so if I look at my equations, if I'm going to find time in this equation, I need to know A, which is negative 9.81, VI, which is 0, and VF, I don't know. So that is out. If I use the second equation to solve for delta T, I need to know A, which is negative 9.81, VI, which is 0, and delta Y, which is negative 52. That's our equation to solve for the time. So I come back here, I'm going to use this equation. Delta y is equal to VIY delta t plus 1/2 the acceleration times delta t squared. And so I've placed my numbers. Negative 52 is equal to 0 times delta t plus 1/2 times negative 9.81 meters per second squared times delta t squared. Well, We'll also notice here that 0 times delta t in the first case, that is 0. Anything times 0 is 0. So we're left with negative 52 meters is equal to 1/2 times negative 9.81 meters per second squared times delta t squared. We solve for our time, and we get 3.26 seconds. That is not our final answer, though. I look up here, and our final answer is supposed to be to solve for delta x. So now that we have time is 3.26, I'll write it in my chart. Now I can go back to my equations, and again, if I solve for delta x, I need to know Vx, which I do is 18, and delta t I've just solved as 3.26 seconds. So now I can use that equation. Vx is 18, and delta t is 3.26, and we solve for delta x by multiplying them together, and we get 58.6 meters. And that is our final answer.